This next section right here, what we're doing is we are moving backwards. Okay, in the previous section, we were given an equation, we make a mapping notation, we sketch a graph. Here, we're given the graph, we're going to come up with a mapping notation, and then get the equation. So what I've done on the very left here is I've drawn a visual of the original basic square root of x function. And then what we have in the center here in blue is a new function that is a transformation of that old function. So what I can do right here is I want to make a mapping notation first. Some of you who are really quick with this can skip this step and get right to the equation. But if you want to start here, okay, we can start off by looking at the starting point, which was originally 0, 0, where the x and y axes meet. And now it's at -4, +3. So that means that we've moved to the left 4 and we've moved up 3. So you can look at that starting point right there and see how has that shifted, and you can get your translations from there. Okay, next up, okay, we can get a vertical stretch. When we're designing equations for these, okay, you don't have to determine a horizontal stretch. Okay, you can consider everything in terms vertical stretches for the examples that we do. So to get a vertical stretch, we're going to compare the first and second point. So let's look on the very left here. Okay, what you see right here is you see the original graph. The beginning point is at 0, 0. Your second point is at 1, 1. So to go from your original 0, 0 to your 1, 1 point, you have to go over 1 and up 1. On the new graph, to get from your first to your second point, you're going over 1, down 2. So because you're doing a horizontal 1 and a vertical 2, instead of a horizontal 1, vertical 1, you stretched it twice as wide, twice as tall. Okay, the vertical stretch in this case right here is a factor of 2. And next up, okay, what we want to do is we want to look at reflections. Reflections you can just visualize. If you look at the original on the left and compare that to the new graph on the right, you can see that the graph has been flipped over the x-axis. Instead of going up and to the right, it's going down and to the right. So if you have a reflection around the x-axis, then your y is negative. Once you have your mapping notation done, you can make your equation. It's going to look something like this right here. And you can check your work by putting this into Desmos and seeing if you get the graph which is given to you in the center right here. That's example 1. We're going to do a second example of this, all right? So once again, okay, you don't necessarily have to write this out, but it may be helpful to have some visuals there, okay? You can see that this original function looks like this, up and to the right, and starts at 0, 0, and the next point is 1, 1. Let's compare that to this graph right here. So once again, okay, I'm going to make a mapping notation, and I want to get translations, reflections, and stretches. So it doesn't really matter with these graphs which you do first, but I like to go with the starting point and get the translations, and the starting point of this new graph is at +6, -4. So the graph is shifted to the right 6, so we have x + 6, and it's shifted down 4, which is y - 4. Those are the translations. There is also a vertical stretch factor of 4. You know this because on the original function, to go from the first to the second point, you go over 1, and then you go up 1. On the new graph, you go over 1 and up 1, 2, 3, 4 to your second point. So you're going vertically by 4 instead of 1, so the vertical stretch is 4. And then finally, is there a reflection in this? Yes, there is. You can see that the original graph goes up and to the right. This one goes up and to the left. So it's flipped over the y-axis. And if you reflect around the y-axis, you make the x negative. Once you have your equation, okay, or your mapping notation, sorry, now you can make your equation. So the y values go on the outside and are unchanged. So we have 4 and -4. On the inside, okay, we have x + 6 changes to x - 6. and then the negative in front flips over. It's still a negative, stays like that. That is our equation.